Hi, hello everyone. Welcome to this webinar. Our topic today is the state of load balancing in 2020. We have our old friend Nathan, who's going to go over this topic. So as some of you who know him, he's been in the load balancing industry for 20 plus years. He's been joining Avi almost since the very beginning. And if you haven't heard the news in 2019 that Avi Networks was actually acquired by VMware. So now we're part of the VMware big family. Okay, and then before we start the presentation, I just have a few housekeeping items to state here. So bear with me for just a few seconds. This webinar is being recorded, so you can view it again on demand. And if you find the content to be really useful and your coworkers couldn't make it to the live time, feel free to forward the on-demand link. Also, you can use the Q&A window to ask your questions. So we have some panelists on the line to help you address the questions in real time. But I'll also ask the questions live to Nathan once he's done with his presentation and demos. Okay. So I think that's all I have to say. I'll turn it to Nathan. And Nathan, you're on.
All right. Good morning. Welcome to the State of Load Balancing 2020. So I'm going to go over a little bit about what we've seen the last year or two and what we're seeing now going forward, and really where the direction is and where the future is of load balancing. So I'm not going to go too far back, all the way back to the beginning or anything that far back, but it's worth noting that there's a couple of interesting highlights of the last few years. There's the obvious bits like we're seeing the world move from software to from hardware to software, and it's some interesting points about people have proclaimed that 2019 was the year of the death of software ownership. People have been moving more and more towards this vision of being able to rent software or pay for what you use, these kinds of licensing models. And certainly all of that is, definitely true, but it's also, I think most of that is pretty well understood. But I want to go a couple of other points that have been really interesting to me. One of which is that we've seen, the first one is there's been a pretty massive shift towards multi-cloud. I don't think this is news to anybody, or at least it shouldn't be, but we're seeing more and more companies and more enterprise type customers that have been moving towards using multiple environments at the same time. Some interesting points here that 84% of all enterprises are now have a multi-cloud strategy. And we're seeing this very much with our customers, that they're running in Amazon and they're running on-premise on VMware, and they're maybe got some other Kubernetes project that they're trying out as well. This is definitely something that we're seeing as an interesting shift in what we saw over the last couple of years. This is really starting to come into fruition, where people are not just having one cloud and experimenting with one or two others, but they're actually running in production in multiple places with different use cases, different workloads. From Avi's customers, this is a rough breakdown of what we've been seeing about the distribution of where customers have been deploying Avi. And you can take a single Avi controller, and you can take that controller and then deploy service engines or load balancers in these multiple clouds simultaneously. So it's something that's been kind of interesting to see, is just this breakdown of our customers. Very much is still the majority of it is VMware. We're seeing, though, that over the last couple of years, we're seeing a little bit of the bare metal is starting to kind of go down a little bit as public cloud has been going up, containers has been going up, OpenStack has been going down a bit. So we've been kind of seeing some interesting trends as there's been some shifts in terms of which particular environments or which clouds that people are moving into. But this has quite a bit of impact on the load balancing space. First off is GSLV. If you're going to have multiple clouds or multiple different environments where your applications exist, then we're looking at things like GSLV. So it's certainly been increasing the frequency and the proliferation of using GSLV to distribute apps across these clouds. But it also becomes interesting because now you run into some challenges with things like management. Do you want to have a consistent experience regardless of where your applications are? So if you want to make one change, for instance, to an application, that application exists in Azure, Google Cloud, and Amazon, you can make one change and then be able to have that change replicate out to all three different applications in all three locations. So that's definitely a challenge that some people have been having. And that's one of the cool things about the Avi architecture, is that it's built around this concept of being multi-cloud first. And the last is that the consistency of APIs. When you're deploying in each of these environments, if you're using something like Kubernetes and you're using a kube proxy or using an Envoy, and then elsewhere you're using an HA proxy, and somewhere else you're using a more legacy hardware load balancer on-premise. Now you've got a different set of APIs to manage each of these different load balancers. And so that's kind of an interesting challenge that people run into, is that lack of consistency and experience means each and every one of these becomes a snowflake. Each and every one of these environments has to be separately and completely rebuilt, repurposed, reprogrammed from the ground up. Just to kind of flip over and kind of give you an example of something like this. This is one of our demo systems that I'm logged into, and I can see on the left a list of all of my applications. I can see that they're all hopefully green and happy, and if they're not, we can go and explore and find out why they're not happy and drill in more. But on the right here, you can see that some of these applications are deployed in the VMware cloud, some are in AWS, a couple of these applications are in Azure, US East Coast. This one's in a Cisco CSP environment. So they're in different locations, data centers, or just simply different environments that each of these applications are in. And you can still have that one consistent experience, which is kind of cool. Another big change that we saw over the last year is RFC 7540, otherwise known as HTTP2. HTTP2 has been around and was ratified as far back as 2015, but really it's started to really come onto its own in terms of actual utilization much more recently. And the reason for that is that for the first year, you saw that there was massive adoption of HTTP2 because Google picked it up. And so in terms of total internet traffic, one or two of the big web monsters like this started using it. And so if you look at a lot of the statistics and such, yeah, there's a lot of traffic, there's a lot of usage. But in terms of number of customers, number of sites that are actually using it, it was very, very, very low. But we started to see that that's really starting to kick up. So there's currently now about 43% of the internet traffic, internet HTTP traffic, is now going over HTTP2. So that's kind of an interesting increase. One of the reasons why this is interesting from a load balancing perspective is that this does a couple of things. With HTTP 1.1, you would open up multiple concurrent connections, usually 6 concurrent connections. And then over those 6 TCP sockets, you'd then be sending multiple requests in. The request would be in parallel across the different connections. So each connection is serial, but you could open up 6 of them, and that way you could have a parallelization. With HTTP2, you open up one single TCP socket, and then over that you can send your requests in parallel. So what this means is that there's a significant reduction in terms of the number of concurrent connections that you'll see on your site. And that's important for things like load balancing in terms of how much memory that it maintains and how its connection management, connection pooling, multiplexing, et cetera. All of these changes are pretty important. One of the other things that's worth noting as well with HTTP2, there's quite a few changes with it, but an interesting one is that the headers previously were just text-based headers. And now with HTTP2, in order to make it faster, et cetera, the headers are now binary. In other words, they're no longer human readable, which is kind of important when you're doing things like TCP dump and you're trying to troubleshoot and such. So you definitely see some interesting changes there. There's an example of going and hitting a website, and an example of something like Google Chrome, where it'll open up 6 TCP sockets proactively for you. And then it gets the response back and realizes, hey, I guess I don't need those other 5, so let me just go ahead and close them out real quick. And so you see all these, basically these terminated connections in there, even though you're like, hey, what's going on? How come I have all of these resets coming in? And that's because people are using Chrome. This right here is just a view of using Avi's, with Avi. If you drill into the virtual service, you drill into the logs, and you can see a full view of what users are interacting, what they're doing with the site. So we go drill into an application, click into the logs, go and expand, find a period of time you're looking at, and then go and take a look at one of the logs and go and see what's going on with them. An example of this, something like this, is now you can do something like view all headers. You can see the headers that are being sent by the client, headers that are being sent by the server, etc. And the point of this is that if you're doing HTTP2, those headers are in binary, which means going and reading these manually is not going to happen. So what you need to do is that in a system, make sure that you're running in a system that has the ability to convert these into a human readable format like this. So put them into something where it's basically usable. Some other changes that have happened as well is TLS 1.3 really came into its own. This is important for lots of reasons. With TLS 1.3, it's got a lot of improvements in terms of new things that it's added in order to make the internet faster. And there's also, though, what's been probably more important is what it removed or took away. So this is an example here showing of just your standard handshaking that's happening. One of the things you can do with TLS 1.3 is fast start. There's a couple of different components here, but basically what this allows you to do is accelerate by removing 1 round trip time. So as you're sending the TLS hello and you're doing that establishment, you send that last ACK along with the HTTP GET. And by doing this, you're able to then remove one RTT and try to accelerate a little bit the entire process. So there's a couple of different tricks in here than TLS that make things a little bit faster and make things more secure. Mostly though, how it makes things more secure is what it's doing is it's removing a lot of functionality. So a lot of the old TLS flavors of ciphers and things like this, all of these old mechanisms are all being ripped out in order to really help reduce the scope and the size of TLS and therefore make it a little more streamlined, which is great. However, there's some challenges with this. One of the things it's doing, making it faster and more secure, but one of the other things that it's doing is that now what you have to do is you must be running perfect forward secrecy. If you're not familiar with PFS or forward secrecy, definitely something that's worth spending a few minutes to learn more about. We actually do have a webinar that has been recorded that you'll find on our website, just specifically around SSL and some of the changes that have come with this, including PFS. But basically what this means is that using your traditional RSA certificate and key are now vastly more expensive computationally. It can be as much as 40% slower. And with this, so what's happening is that RSA is out, and elliptic curve is really where all the new certificates are going, because basically what's happening is that elliptic curve is much more friendly in terms of computing PFS ciphers. And what this basically means with perfect forward secrecy ciphers is that it makes sure that somebody can't record a connection and then decrypt it after the fact if they steal your certificate key or acquire it somehow. And with PFS, basically it's something you were able to do in the past with previous versions of TLS, but for the most part, no one did it because it's too expensive. Now with TLS 1.3, it's mandatory. You must be using perfect forward secrecy ciphers. So it's definitely something worth spending a few extra minutes and learning about. But what this means is that you really want to be leaning towards picking up elliptic curve certificates and keys rather than your traditional RSA certain key. One other piece that's also worth noting is that things like NPMs or man in the middle, anything like this where you're tapping off the wire and then going and using this for any kind of network visibility tooling and such, all of these tools are going to be blind. In the past, you used to be able to go and put your RSA key and just put a copy of it on those man in the middle type devices, your firewalls or NPMs or IDS, etc. That's no longer going to work when you're using forward secrecy. So forward secrecy is great because it solves a lot of really important security vulnerabilities. But on the other hand, it also means there's some changes that you need to be aware of. So that's definitely one thing that's been interesting to see is the adoption of TLS 1.3. There's a lot of caveats and things that are worth noting and worth learning about. But so this has definitely been one big trend that we've seen coming up over the last year or so, is that this is becoming a widespread. So it's definitely worth looking into. And the last one from last year that I think is one of the most compelling events that have happened is just the market is changing. There's been a lot of acquisitions. All the top hardware appliance vendors have been exploring having themselves sold off. It's been kind of interesting to see as they've been shopping themselves around, and there's not exactly been any buyers for hardware load balancers anymore, which has been kind of interesting. In the software world, we saw NGINX is sold, and also, and what I would consider to be definitely most important, was Avi Networks is now part of VMware. So hopefully that's not a surprise to anyone since Leigh already kind of mentioned that. And because you're on a VMware PowerPoint slide deck here today. But this is definitely something that's been interesting. It's the market is changing. And so kind of what is the impetus for this? What is causing and driving all of the kind of this reshuffling, if you will? And I think there's a lot of things that are going on. What's interesting is that the load balancing market has actually been growing and growing pretty nicely. But what it's been doing is it's not been growing in the same way that it's been growing in the past, where people just simply keep buying more and more of the same hardware load balancers. That world is basically kind of run dry and coming to an end. And so people are having to rethink and redo things a little bit differently than how they've been done. And not every vendor has been able to adapt to that. So I'll come back to this in just a bit towards the end here and kind of circle around with some other trends that are happening. So with this, Avi Networks is now part of VMware, which is pretty cool. So more interesting now is for the state of load balancing is kind of where not just where it has been, but predicting the future, where are things going? And this was when it gets a little bit more fun, a little bit more challenging. This is where I'm going to go and have egg in my face in a year's time when none of these things come to fruition. But in the meantime, I'm going to go and put some put some things out there. One of the things that's not too hard to predict is, hey, HTTP 3 is around the corner, and this is something that's moving along full steam. So just when we find they're getting HTTP 2 really rolling out and starting to see this going into mainstream, and now we're throwing out HTTP 3. There's a vast amount of time between when HTTP 1.1 came out and HTTP 2. There's not a whole lot of change, and things are pretty quiet. And now we're seeing quite a bit of movement, and this is true across the entire industry. The way the application's been designed, developed, consumed, etc. HTTP 3 is still HTTP, but the transport layer that it's running on top of changes out a little bit. So we're basically swapping out TCP with UDP. It's a connection-based UDP, which is a little bit interesting. So you still have what basically is your three-way handshake. A lot of these things are still happening, even though it's happening over UDP. And why this is interesting is that this allows you to kind of get around a lot of things like some congestion controls, slow start, and basically what could happen is that with HTTP 2, it did a couple of great things about really improving the performance by allowing you to parallelize and have multiple requests all running over a single TCP socket. So you can make 10 different requests, sit back and wait, and the server would stream back 10 different responses, all over the same TCP connection. However, if you get a packet loss somewhere in there, then that whole TCP connection is obviously slowed down. If you have multiple parallel connections, then if one of them gets slowed down, life is good. You're not hurting. So in some ways, we're kind of going back to the idea of multiple connections. But in this case, because it's running over a UDP, it's not quite the same thing as TCP and having multiple TCP sockets open. So basically, what this allows us to do is have multiple streams running concurrently over UDP/quick connection. So it's definitely changing up the way that load balancing behaves, because now we're again going back to how multiplexing is working, how connections are handled. So this is definitely one interesting thing. What this also allows us to do is this allows us to send a lot of data very, very quickly without having to go through a lot of that TCP ramping and slow start, et cetera. So it allows us to stream more data. And the assumption here is that most network connections are relatively fast. Packet loss will occasionally happen, but let's not just immediately slow down everything. Let's keep being a little bit more aggressive. Some of the other things that also come with this is that some things like the header compression is done a little bit differently, just because you are eliminating some of the head-of-line blocking problems. So there's definitely some changes that are there and under the hood here. What this also allows us to do with HTTP 3 is this allows us to get into other protocols and be able to run them over the HTTP protocol, which is really intriguing of what's possible. For things like APIs and such, they just need to be able to send a real quick burst and just send, here's a request, here's a response, pack it in, pack it out kind of thing. Running this over UDP is definitely has a lot of ability to really speed things up quite a bit. Some examples of this is that there's been a lot of movement towards doing things like basically killing DNS and moving DNS over HTTP using HTTP 3. So it still would be a DNS resolution that's occurring, but instead of having it occur over DNS as the transport protocol, it would move all of this over into HTTP being the underlying transport protocol. And this, or specifically, it would be UDP running on quick. So there's some interesting elements to this. The reason for doing this has a lot to do with the fact that right now when you're doing DNS, it's just a pack it in, pack it out over UDP. Life is good, it's quick. But if you want to do something like any kind of security, you have to implement DNSSEC, which pushes it over TCP. And DNSSEC has basically been a bit of a non-starter. It's been way, way too heavy of a protocol. And so because of this, it's something that's just too computationally expensive, too heavy a protocol, and it's something that's just simply not being adopted and widespread so far. And so the industry is looking for, how do we provide better security? How do we provide better authentication of the server? How do we provide a better means of mitigating some things like amplification attacks? You know, what can we do with this? And so one thought is by moving it over to HTTP, that allows us to put over specifically HTTPS using Quick, and this would allow us to use fewer packets. When we get into things like TLS 1.3, we have these zero RTTs and these abilities to start removing some of the round trip times. Now it becomes a little more feasible to be able to do this. So there's an interesting debate going on right now of, should we move DNS over to HTTP, which you'll see as DOH, or should we just simply push it over TLS, which would be DOT. So it's an interesting fight here. Do we keep the DNS protocol as is and simply keep evolving it, or do we just basically dump it and go over HTTP? There's a lot of pros and cons for both. It's kind of a fun debate to follow. My prediction here is I think that DOT is going to win out by the end of the year. over HTTP. So pushing for DNS over HTTP is going to be your vendors like Cloudflare, Mozilla, Google, pushing very aggressively towards DNS over HTTP. On the other side, you have things like a lot of more enterprises are pushing for DNS over TLS, which gives them a little bit more control, a little bit more capability to secure things. So both are very interesting, very viable alternatives, but one way or another, DNS is changing. So this is something that's kind of interesting to see for us because DNS is the second most common protocol that we see deployed in Avi. One of the things you're seeing a lot of is that a lot of buzz with things like moving into containers, container-based networking. You're seeing microservice-based architecture. So people are going from the web, the app, the database to this container-based architecture. We've got all of these apps intercommunicating with each other, and now we've got all of these microservices. You take these big apps, break it up into all these microservice-based apps, and as we do that, now we've got all these little tiny apps that are all chatting with each other. So one request comes into Facebook, that request then internally becomes about 100 requests and going to all of these other billing applications, the authentication app, the caching app, the portal app, and all of these smaller microservices. And then providing the networking for this and the plumbing for this becomes really interesting and quite a bit more challenging than your traditional web app database. For the last couple of years, we've really seen it's all been about service chain, service chain, service chain. And typically that's really been fairly narrowly defined as the layer 2 to layer 3 connection. How do I connect this device to that device? And what you're seeing now is a move towards more of service mesh. And this is really, I think, going to be 2020 is going to be, if you look back on this, I think it's going to be the year of service mesh. And service mesh in some ways is the same concept of its interconnectivity, but it's more of an interconnectivity between services rather than an interconnectivity between devices. So by services, what we mean is these microservices, the applications, rather than just this box needs to talk to this box, we start and take it up a level and say, it's how these applications are interconnecting. And now what we're doing is it's a little bit more of an orchestrated solution rather than just simply an underlay or just simply an overlay-based network. So as we start getting into some of these more orchestrated solutions, what you're having is you're seeing a lot more push towards this automation of these services. So you traditionally are kind of looking at things like Istio is a real common one that you're going to hear more and more about. And there'll be a lot of other ones around this. But a couple of things I want to make a point of here is that I'm not going to go down the rat hole of all the details of service mesh necessarily. But what's interesting is that all of these applications, as they're coming online, they're being built up, being torn down automatically. And you may see these applications coming and going, hundreds, if not thousands of them in very, very short periods of time as applications become very bursty. What happens is that this all needs to be automated. This is something where you're not going to go and spin up and tear down hundreds of applications and then in the meantime go and open up a ticket with the networking team to go and I need to go and change this, add this to the firewall. What's going to happen is that all of these things, and the point of service mesh is that now we're moving towards an automated system of taking advantage of integrating these things. So I want to go and spin up an application A. It needs to talk on this NIC. It needs to talk to these other applications. It needs access from the firewall to do these certain tasks. And so we're getting to the point now where instead of having a human going and taking advantage of, let me go and log in, let me go and add this, add that, it's simply not fast enough. It's simply not sustainable enough. So you're getting into these CI/CD pipelines where applications are coming and going, changes are being made at a very, very brisk rate. So we're seeing more towards things like Istio and other service mesh-based orchestration tools. In this case, Istio specifically around automation and orchestration of the container-based networking. But there's a lot of other changes that are happening along these lines. VMware is very much pushing very aggressively into this space as well. But what you're looking at is a lot more of this as being more of a framework for where the industry is. So right now, today, you've got all these disparate different islands of technology, and trying to plug them on, trying to make them all work together, trying to make them all behave together is what gets interesting. So kind of looking ahead, you're going to see a lot of buzz around service mesh and kind of some of the capabilities of what this can do. So the ability not just to interconnect two devices together, which is kind of more of your service chain kind of a feel, but now getting a little bit more intelligent about the discovery, providing the full visibility, the controls, security, et cetera. So there's a lot of capabilities that are here. And this is where we're going to see the industry going over the next year. You're going to see a lot of buzz about this. Well, taking it a step further, just kind of tying some of this stuff together about where is this stuff going and what's the future of all of this. You're seeing right now is that a lot of industry trends, and if you've attended any of the workshops that Avi provides, really gets into some of the details about this and takes it out of just a couple of 2-3 word sentence here, and actually kind of gets into some hard examples of this. But some of the trends you're seeing is that you would, every time you'd upgrade your load balancer, upgrade your device, you get all these new features, and the wall of knobs just gets bigger and bigger and bigger. The certifications get that much harder, and just as you just have more and more featureitis. What we're seeing is an industry trend to just simply move away from that wall of knobs concept and move towards an ease of use. You're seeing this in a lot of products today that are really kind of going through and revamping themselves and rebuilding themselves and saying, how do I simply automate? How do I take advantage of artificial intelligence and kind of more intelligent ways of building, designing, and deploying applications, or deploying networks, or deploying these different types of services? So we're seeing a big move away from this wall of knobs concept to say, what is it that really needs to be exposed to the user? We're seeing a move away from things like 5 nines of uptime. It used to be that everywhere you go, I'd always get asked, so how many 5 nines of uptime are you guaranteeing? And what's your SLA? And this is our SLA. You really don't hear that in the same way anymore. Yes, companies are absolutely worried about it and concerned about guaranteeing uptime and guaranteeing availability, but you're seeing one of the trends is moving towards an expectation of failure. Failure is going to happen. So now, if a failure happens, how do we resolve for it? How do we fix this? What do we do? What's the actual task? Some good examples of this is that with something like your active standby load balancer pair, how often would you just go ahead and unplug the active load balancer and just pull the power plug on it just to see if the other one would take over? For the most part, no one would ever do that. Why? Because, well, what if it failed? Well, yes, but what if it failed while you're on vacation or at night or something like that? And so that kind of mentality of like, yeah, don't touch it. As long as we don't touch it, it'll stay up. And we need to make sure that we're making our 5 nines of uptime. The world's moving more towards this concept of failure is going to happen, be it hardware failure, software failure, or more likely human error. So when that happens, let's build a system that's resilient and can intelligently be able to absorb that failure and do something about it. We're seeing a big move from pets to cattle. Pets, things like your active standby kind of a load balancer pair, and if one of them dies, we have to arm it and take 6 weeks, to more of a cattle, which is, I've got a fleet of load balancers. If I need more capacity, the fleet will grow. If one of them dies, I lost 1% capacity in the fleet, and simply I've got a fabric that can elastically absorb or increase or decrease capacity as needed. So it's very much a different mentality, a different way of looking at the world from your active standby kind of mentality. So in this example here, I've got this virtual service called Avi Demo that's pointing these 3 pools of servers on the back end. And this one right now is running active on 2 load balancers. And if I need more capacity in the system, I can simply go into my application and just say scale out, and that'd be running on 3 load balancers would spin up. It's just a matter of, do I need more capacity? I need less capacity and scale in, scale out, or I can, of course, have the system automatically do this for me. And the point is that I'm not managing load balancers anymore. I'm simply managing a fleet of cattle. If I need 2, if I need 200, it doesn't really matter. It simply becomes more of a capacity driven. This is an example specific to Avi, but you can take this across the industry. We're seeing this in a lot of different places, in a lot of different ways. And then last is we're seeing kind of an industry trend from moving away from this concept of, checkbox kind of, do you work in this environment? Do you work in that environment? And there's a massive difference between being able to install in an environment and be able to integrate with an environment. And this is something where just kind of at a high level, we kind of get asked these soft core questions of, and like, hey, do you work in Azure? Yes. That's a whole lot different than, are you fully, completely, and tightly integrated with Azure? And that's the kind of a question that we don't get asked as often as we should. But we're seeing this happen a lot more now, is that people are starting to ask a lot more questions around define and show and what can you do? What does your integration really do for us? And that's really cool to see that people are starting to ask that. But I think this is definitely a trend that you're going to see more and more of. And it's definitely something to be aware of. As you're looking at something like, does your product work with XYZ? How does it work with that? What is it actually doing? Why is it, as opposed to, yeah, both their product works, our product works, so it's probably good. So I'll give you some examples of that. But really what this comes down to is that we're the destination of where all of this is going. So there's a lot of interesting features, and we can go through the, I went through a lot of things like some service chaining, and service mesh and HTTP2 versus 3 versus these other kind of components. And there's all these different things, individual technical points that we can hit on. But what's interesting is really those are the how. This is how we get to our destination. What is the actual destination? And it's kind of sometimes important to just kind of take a step back and say, let's state of load balancing here. Where is load balancing going? What is it that's leading towards? What is it the industry is moving towards? And what we're really seeing, if you kind of take a step back, is the industry is moving towards automation, yes, but it's moving towards this concept of, I want to be able to deploy an application. When that application deploys, I want the networking underneath it to instantiate. I want it to figure out what I need, figure out how to make it happen. And if there's a problem, let me know. Otherwise, just do what it is you need to do. And that doesn't mean that any of the intelligence has to go away. That doesn't mean that somebody isn't on the other end of this that's controlling and managing all of this. But what it does mean is that you go from that 6-week ticketing process of, I'm going to open up a ticket to deploy an application, then open up another ticket to get an IP address, then open up another ticket to get an SSL certificate. And you go through this whole long process just to deploy an application versus my application is ready to go, hit the publish button, and it's now uploaded online, and a few seconds later it's deployed. We're seeing a lot of customers that are moving to things like public clouds, like Amazons and Azures and such, and they're not necessarily moving there because it's faster. They're not moving there because it's cheaper, because it's more secure. Really, what it comes down to is, it is from an application owner's perspective, it is easier because they can simply upload it and things just work. If we're doing this on premise, it's like, I've got to go through this full ticketing process, and this looks a little bit more like this. I want to create a virtual service and deploy an application. And your process is, I've got to go through all of these different steps all the way throughout. And what the exact steps are, they're going to change a little bit for everybody, but it's going to look something like this. Versus, I just want to deploy my application and make it go. Let computers do what they do, which is let them do repetitive tasks and let them do that kind of thinking for me. Kind of give you an idea of something like this. So I go into my virtual service. I've got a Avi controller here that I'm logged into. If you're not familiar with Avi, when I'm logging into an Avi controller here, I'm logging into just a system that controls the Avi fabric, but I'm not logging into individual load balancers. With Avi, you'll never log into a load balancer. You're only going to log into the controller, and it will deploy the load balancers. So I have no applications created. I don't even have any load balancers created. And I've got this really cheesy self-service portal. It's just a simple HTML page, but I can go through here and I can create a new application, give it a name, say it's HTTP, HTTPS, whatever it's going to be, and exactly what knobs you choose to expose in something like this, kind of a sample self-service portal. I can say, go ahead and deploy this. So I'm now going to upload my application, give it some parameters, and away we go. On the back end, what this self-service portal is doing is it's firing up this little macro API. And this API, then I can then copy paste this and basically publish or post this to the Avi controller. And what that would do is that API then tells Avi to go and create the virtual service and do all of these 17 tasks. When I flip back here, though, what's actually done is it's posted that to Avi. And what's created here is, here's my virtual service that's pointing to a pool of these 3 servers. Right now it's showing that it's red and it's down. Why is it down? It's down because I don't actually have a load balancer. So I've never actually deployed a load balancer in this environment. I've just created an Avi controller. I have no load balancers. I have nothing else created. Over here, I didn't say anything about what load balancer I want, what size, what networking parameters. I didn't tell it anything about things like anti-affinity. So if I need to deploy a couple of load balancers, active, I want to make sure that those 2 load balancers aren't running in the same physical host. I don't know anything about, is this on VMware? Is this in Azure? I don't really care. I'm just saying, application developer, here's this self-service portal, upload your app and give me some parameters that I expose to you. And on the back end, what's happening is that Avi's spinning up a load balancer. In about 2 minutes or so, these load balancers are going to fire up. They come online. The application will turn green and life is good. My first load balancers are created. My application is there and I'm underway. And the point of this is that this takes us back to this model of, I didn't have to go through each and every one of these individual steps. A networking owner has already gone through and basically told Avi, here's how I want you to deploy. Here's how the sizing, here's where I want you to deploy in these environments, not those. Here's how I want the networking to work. Here's when I want you to automatically scale out capacity or scaling capacity. All of that environment has been told to Avi, and now the Avi controller can go and simply just execute these steps for me. And with that, it knows how to go and deploy applications. And now I can go and upload hundreds of applications. I can push terabits of traffic. And my application owner doesn't really need to know or need to be exposed to that. And this is kind of a bit of the destination of where we're seeing most enterprise customers going to. And they'll have different terms and different names for these projects, and they're still kind of loosely defined, but it's really moving towards this kind of concept of self-service model. Of an application owner can self-service, and they can deploy their application, and the networking doesn't take weeks to happen. It's something that happens very, very quickly. It also doesn't take them very long to go and do something like if they deploy their application, they can go into it and troubleshoot if there's an issue. So they go into the application, somebody says that there's a problem. They don't necessarily have to open up a ticket to get every little bit of detail. They can go through and they can look at something like this. And I'm looking at this example of this application that's been pushing traffic for the past 6 hours. And somebody calls in and says, hey, the site's been slow. Yeah, I can see that this spike in time here, this one in the middle is orange, and that's caused by the app response time is slowed down. I can go and see what's going on with this, understand the breakdown between the client networking time, the server side networking time. The app response time normally was orange here at 35 milliseconds, and here it's spiking up to 75 milliseconds. I can go and drill in and show you every detail about why we're seeing these slowdowns. And this is kind of the point of that self-service model, is it translates into networking automation. It translates into things like just a change in how services are consumed. So things like how we've got application teams that are able to go in, self-service, take a look at errors here and see what's going on. And it says, hey, this site, this particular request is an error because the app response time was high. We can go through and drill in and understand, let's mouse over that and say, show me anything over 100 milliseconds or whatever it is that they're looking for. And the idea is that you can have your application teams not be able to impact the networking necessarily, but they can still self-service. They can still figure out what's going on with their applications. They can go and see if there's an issue. And this is kind of all of these levels of different forms of automation. So we can see which servers here are sending out these slow responses, for example. And with something like this, we can see that 99% of all those slow responses at that point in time are coming from the .12 server. And the app teams can go and figure out, hey, what's going on with my .12 server, and determine what that issue might be. Here's my other application that's turned green. There it goes. Now I can go and create a second app, and life is good. So as we start deploying applications, boom, we'll see the second application come online. New VNets are being created for that new network it's going to connect to, and it's going to come online in a couple of seconds, and away we go. And this is kind of the point of where all of this is going, where you're seeing all of these kinds of these movements towards all of these technologies. A lot of these technologies are definitely important, but these are really a lot of the hows. The destination of where we're seeing the state of load balancing is that it's going towards not just being installed in an environment like an Amazon or a VMware or whatever the environment might be, is it's really being able to be integrating with that environment and integrating with the ecosystem around it. And by starting to chain together all of these services, even services like DNS, like SSL to automatically acquire a certificate, like IPAM to pick up an IP address, all of these services are now kind of part of this whole uniform collection of services that we define as this whole chain. So when I deploy my application, all of these need to work together. When I go and spin up a new application, that means that the load balancer now needs to talk to these destination application IP addresses. And that means that the load balancer needs to talk to the firewall to tell the firewall, hey, I need permissions to talk to server XYZ. All of these need to happen automatically. Otherwise, we're back to opening up another ticket. So this is what we're seeing is a lot more integration, not just, hey, I can install in this environment. It's really, how can I make this into one single cohesive ecosystem? And this is what we're seeing. This is where we're also finding that your traditional hardware load balancers have really been kind of falling flat a little bit on this. They're kind of looking at this as saying, I'm a big bad load balancer and everyone has to come and talk to me. And Obvious approach is really more a little bit different, which is to say we're an important and vital component of your network, but we're just simply one component. All of these components need to work together, need to behave nicely with each other. They all need to start integrating. And if they don't, then you're really not going to be able to build something that's able to do this network instantiation, this automation. You're not going to be able to scale to having 100 times more applications on your network because you're not going to hire 100 times more people. So this is really where we're seeing the industry going. There's a lot of technical components that make this up and that underpin this, and each of these is really worth quite a bit of a longer discussion. If you're interested in longer discussion, happy to go through that. We have classes that go over this, but I think it's what you're going to see more and more of is that there's been a lot of transition and change in the market of late with things like different load balancers that have been trying to sell themselves off, with things like Avi specifically being acquired by VMware is that part of being acquired by VMware is that we're part of a larger story here of integrating with things like NSX, integrating with on the networking side, but then also integrating with a lot of other technologies on the networking side, on the automation tooling, network visibility, and analytics. But also, though, at the same time, we have that ability to be agnostic. So Avi is able to work with any major public clouds. We're able to work in Cisco CSP environments. We're able to work in basically across the board to be able to provide that uniform solution that basically you can deploy an application, and that application can be deployed in any different cloud and still have that same level of network automation where I simply deploy the application and away it goes. I don't have to go through this whole wall of knobs or the complexity that comes with it. So if you want to know more about any one of these topics, these are all a lot of snippets of topics that come from the Avi Networks workshops. So if you're interested in joining one of our workshops, they're 2-day workshops or 2-day classes that are free. And we really get into and explore a lot of these concepts a lot further, as opposed to just a quick 40 or so minutes topic. So with that, Leigh, do we have any questions?
Yes, we do. But before we get to them, I just have a few things to say. We've received emails offline saying that this is a great presentation. When can I get the recording, the slides? So you're going to get an email with the recording and the slides shortly after the webinar. If you don't, reach out to us at Avi-Marketing, and we'll make sure you get a copy. Okay. Now let's move on to the question. So we have a question from Jason. He's asking, in the self-service portal demo, how does the controller know what capacity to provision for the service engines? That's a great question. Nathan, if you're talking, we can't hear you.
Okay, sorry, mute. So Avi is plugged into a number of different clouds. In this example, I've deployed my controller, and from the controller, we've gone and created a number of clouds that it's connecting to. So I can go and create a new one and say, I want to set up a new Google Cloud or whatever it's going to be in this environment. So that basically enables Avi controller to now know how to talk to that cloud and that environment. Now within that environment, then we're going to deploy load balancers or service engines. So we have a concept of a service engine group. I'll pick on VMware. So in this VMware environment, we're going to create a group of service engines. So I can go and take an existing one. I'll just create a new one. In the service engine group, new SE group. So in the service engine group, we can set up things like, do I want my high availability, how I want this to behave, a lot of other details. But in here, I can set up the minimum saying, by default, when I spin up a new load balancer, I want it to be 2 gigs of memory and 1 CPU core. And so by default, when I spin up a new service engine, if I don't provide any other details, this is what's going to spin up. And if I don't have enough capacity for this application, let's say you start pushing 100 terabits of traffic, then I can automatically spin up and go active across 2, 3, 4 service engines. And certainly I can go and change this to being something much larger as well. So if you want that to be something, if you want to have a very large load balancer, you can predefine that and change this. So this is what it would look like in something like VMware. If we do the same thing, but I do this in something like, let's say, AWS. In AWS, they do things a little bit differently. And instead of what they have is with flavor, an instance flavor. So in AWS, I'd say I want to deploy on a service engine to be a C4 large, which is basically the same thing. It's just a C4 large is going to be predefined as 4 CPU cores, 12 gigs of memory, et cetera, et cetera. Wait.
All right, let's move on to the next question from Daniel. Daniel is asking, how does Avi handle geolocate functionality?
Okay, so for geolocation, being able to determine where users are coming from, going to, et cetera, we have built in a geolocation database. So there's 2 different levels of geolocation databases that are built into the system. But one of the things you saw or might have seen here when I flipped into something like the logs is in this particular client 23.something is coming from the US. So that's coming from a geolocation database that's already on Avi, on the controller. And the controller pushes this down to the service engine so that they have this database and they know where you're coming from. So there's 2 different levels of the database, one of which is just this country level at a high level here. And then there's a second level that's latitude, longitude. So if you want to be able to say specifically, I'm coming from San Jose, California versus LA, California, so I can direct me to the right data center. So either, we'll use either one of these databases depending upon the level of granularity that you're looking for. This is based upon the McMahon database, and you can override this with your own, or you can update this as necessary. So we see a lot of customers do that, particularly for things like GSLV.
Yeah. And then the follow-up question, what's the current maximum LAN connectivity for Service Engine?
What's the first one? What's the current connection? Can you repeat that?
Maximum LAN connectivity for
LAN
service.
LAN connectivity, you can be using 1 gig, 10 gig, 40 gig NICs, 100 gig NICs. You can bond these together if you need to have, 240 gig NICs bonded together. So it's really it's a function of the hardware that we're sitting on. Obviously, it's just software. We don't provide any hardware. So we deploy whatever hardware that you have. So if you're buying a Dell server with a couple of 40 gig NICs, bond those together for an 80 gig pipe, away you go. Yeah, that's really up to you at this point. We certainly prefer modern NICs that are DPDK supported, that are kind of more conventional and such. But you can put any NIC in there. It can be deployed in physical bare metal, where we just physically take over the NIC, or we can be deployed in a VMware environment or another similar virtualization environment. It's really up to you. And of course, if you need more connectivity, let's say if you're putting us on a server that has a 10 gig NIC, and you need to have 100 gig of capacity, we can simply scale out our service engines active across multiple physical servers as well to increase capacity.
Yep. And then what is our plan to support IPv6? I don't think we need to commit to any timeline, but just want to have a quick comment.
We support IPv6. Just put in a V6 address versus a V4 address. Okay. Or you can mix and match as well if you want to do, if you're looking at doing any kind of gateway functionality between client and server, which is pretty common.
Got it. Okay. So Brendan asked us a really, really long question. I'm not actually be able to read it during the webinar, but I did assign the question to you. So Nathan, take a look. But I can answer his question on a high level. So his question is mainly around what's going to change with Avi products with the acquisition from VMware. So in general, we are actually continuing to sell as a standalone load balancer supporting multi-cloud environment, not just VMware environment. Of course, we're going to continue to integrate with VMware ecosystems, right? So that will not change. So all the features that you see, or if you're existing customers, they will remain the same. And then we will further our integration with VMware products. And then in terms of relationship with F5, and obviously F5 is one of our largest competitor. We'll continue to innovate in the load balancing space head on with F5, and that's kind of what I can say. Unless Nathan has some additional comments.
Sure. And the first bit of it, I haven't seen the question, so let's see if hopefully I answer this correctly enough. But on the first bit of it, run the integrations and such. Just as I said, we'll continue to be a standalone. Really, what the point of Avi is that we need to be agnostic. We will need to be integrated with all of these different adjacent environments or ecosystems where you could deploy. So we have incredibly cool and tight connections and integrations with Amazon, with Azure, with Google Cloud, with Kubernetes and such. A lot of capabilities, because we're a controller-driven architecture, we can directly and really tightly integrate with these environments, whereas a more traditional appliance simply can't. An appliance is simply an isolated island of technology, and that just doesn't really work. It's not intelligent at all outside of itself. Whereas with a controller-driven architecture, the Avi controller-driven architecture integrates with the Kubernetes, which is a controller-driven architecture, with Amazon, with Azure, with VMware, even vCenter, with NSX. There's a lot of examples like this. So that's really the advantage of Avi, and that's really the point of why VMware wanted to acquire this, is VMware still wants to be able to remain agnostic and go wherever the application workloads go. They want to be able to provide that capability. But at the same time, we are doing a lot of tighter integrations with VMware specifically, things like with Horizon, with NSX. you're going to see a lot more around that over the next years. A lot of integrations that we've been working on are going to start rolling out, which is going to be pretty exciting. And I think what you're seeing is that a lot of, in the case of something like NF5s and such, they've really been kind of running out of steam in terms of the hardware load balancing space is just kind of, that's as far as it's going to go. You can't take a hardware load balancer and put it inside of Kubernetes or put it inside of Azure or Amazon or any of these types of next generation destinations where applications are going. And so they're very quickly like, well, let's take the software, rip it off of the hardware, put it onto a VM and call ourselves SDN. And that's kind of what's been happening, is very much this lift and shift, which is vastly different than a tightly integrated system, which is, there's so many examples of this, and we've got some good webinars that really just cover those examples as well. But I think that's what you're seeing, is that's why they're kind of struggling a little bit, trying to figure out where their destination is going to be and where they're going, trying to find other ways to sell you more products and more things. When at the same time, you're seeing that the industry is really moving away from the architectures, things like the web, the app, the database, that kind of three-tier architecture model are really starting to go away. And with that, those architectures of how their load balancers are designed and developed, they're looking a little long in the tooth. They're developed 25 years ago, and it's starting to show.
Yeah, we have a question from Roger. And his question is, are we talking about GSLV? What you mean when you say we need to host URL like F5 GTM and it redirects to Avi virtual service? Does the question make sense?
The question doesn't quite make sense, but I'll see if I can take a stab at it. Not necessarily. Usually, in most cases, first off, yes, we can integrate and work with. Integrate is a really soft word there. We can definitely work with other GSLV solutions if you have others like GTM today. Avi, of course, does provide GSLV services as well. So you can, Avi does provide GSLV. It's not something that we charge for. It's something that if you have Avi, you have all of Avi's functionality. WAF, GSLV, client authentication, all of these functionalities come with Avi. So it's not a separate product that you have to purchase. It's just simply different functionality that you have to use. Created basically a DNS virtual service that's doing GSLV functionality. So it's definitely something that you can use, or we can work with other GSLV solutions if we're just going to be the load balancer by itself. So either way is perfectly acceptable. But yeah, try it out. Clay, what else do you have?
Yeah, Raju said his question is about how Avi GSLV and Avi virtual service communicate.
Okay, how they communicate?
Mm-hmm.
Wow, this is come to one of our classes. Well, we really get into it. So how they communicate is they're done a little bit differently. If you're coming from, like, it sounds like you're asking about GTMs and therefore F5. In like that kind of a world, you had these two different products. And these two different products, while they're based on the same operating system under the hood, they're completely different products. With Avi, a DNS virtual GSLV is just a virtual service that's running DNS. And with that, we simply light it up and say it is going to be doing our GSLV. So GSLV is going to have a few extra different functionalities. But all it is it's another load balance, another service engine. It can be the exact same service engine. The service engine can be created when we create a virtual service, create it in advanced mode. I could create one in, I don't know, VMware, wherever it's going to be. I can say it's going to be HTTP. I can say it's going to be running DNS. And when I tell it's going to be running DNS, then I can go and light up some additional DNS capabilities here. So real quick, it's just once that GSLV service is up and running, now I can go and create an application that's going to be my www app or whatever it's going to be, www.gslv.com, roll through and just create these functionalities like this. What this is going to do now is I'm going to say point to in my US data center, it's going to point to app 2, and in my, let's say in my AWS data center is going to be pointing to this other app. So it's pointing to two different applications that are two different virtual services. Simple as that. So it kind of comes back to a higher level of, I've got a centralized controller that's managing one or probably hundreds of load balancers. These load balancers can be running GSLV, they can be running just normal virtual services, but to these load balancers, there's no difference. These are just two different virtual services. One is HTTP, the other one is DNS. So it's kind of a longer question. I don't really have the slides queued up to kind of illustrate this, which would make this a whole lot easier. But yeah, that's a quick version
Roger
of it.
said he actually got it from her brief explanation. But for the audience, if you'd like to learn more about GSLV, there are two ways. One, we actually recently did a webinar branded under Avi Tech Corner, so very technical webinar that our engineer talk about GSLV in detail, deep dive on GSLV. Just go to the avnetworks.com/webinars, and you should be able to see the GSLV webinar recording there. That's one way. Another way is, as Nathan indicated, this is a pretty complicated topic. And in our 1.5-day workshops, which is free, offered to the customers and prospects, Nathan will go through the GSLV topic, actually, is one of the topics on your workshop in detail. So you can ask them all the questions you want. We are reaching the top of our webinar, but there are two more questions, so I'm going to ask them really quickly. Hassan asked the question is, does Health Monitor support send and receive get string?
Yes, absolutely.
Okay.
So you can get as complicated with that as you need.
Okay. Another question is from Darren. I think that's a follow-up with the IPv6 comment you did. He's just asking which version we start supporting that. And I think I actually to just make sure that of that myself, I actually went to our KB site and just dial and just try to search for IPv6. Nathan, if you would show the audience how to find information about certain support, like we detailed our support on which versions that we start supporting certain features, which environment, what's the limitations, and so on. So if you just simply search for IPv6. There are, more details there, but there are also, I also see in the KB, it kind of indicates certain environments is not supported yet. So if you want to get further information about whether your environment has the IPv6 supported, you gotta send an email, reach out to us as well. Okay, one last question from Daniel again. What is the comparative capability to iRU function in F5's TM message? Great question.
You said iRule function?
Yes.
Sure. So similar functionality to iRules is there's two things. One of which is 75% of what you can do in iRules, you can do with native point-and-click functionality with Avi, and that's very much by design. There's a couple different ways of doing something like this. Give you a quick example. We'll go into an application profile, go into security, and one checkbox here to do things like encrypt your cookies, HTTP to HTTPS redirect. To do a lot of functionalities that you would commonly do, we've basically made these common functionalities and just made them be checkbox. So 75% of all of the iRules that you have in place today are things that would just go away and they just be a checkbox, which makes things tremendously easier to manage. And it's also computationally a lot cheaper because now you're doing these in C rather than in Tickle. If you need to do something a little more complex, and actually do something ski off the rails there a little bit, go into something like policies is one way, and you can do, again, kind of more point and click and say if the, let's say if client's coming in on a specific port, then I want to go and do whatever it's going to be, pick a port. Then I want to do a redirect. I want to, let's say, send them to a different pool of servers, do something more interesting like this. So this is kind of another way you can kind of still, it's not quite as powerful, but it's still something where it's very simple and very easy to set up. If you want to get into the more ski off the deep end kind of thing, this is when we get into data scripts. And data script is data plane scripting language, very similar to iRules. It's based on Lua instead of Tickle. It's basically the same thing except a 25-year newer scripting language and with less squiggly brackets.
Okay, I lied about the question. I'm trying to get Samer's last question, and is, does the VIP mask the client's IP address?
Does the VIP mask the client IP address? If I understand that correctly, by default, Avi is snatting. So the client IP addresses that is sent to the server would be the service engine's NIC interface. But that isn't, that's the default setting. You can certainly change that as necessary. But if you look in something like in the logs here, we can see here's the original client IP address. Here's the virtual service they're connecting to. This is the IP address that Avi is snatting from when we're sending it to this server address. So all of this data and all this detail, every connection, every request, etc., all of that data is logged here and can be exported. If you're using something like Cisco Tetration, for instance, they're actually going and pulling from Avi's logs in order to get this information of the original client IPs, etc. Now, if you don't wish to snat, then it's simply a functionality that you simply just turn off the snatting. So it's very easy to do.
Can you translate, do you have a migration tool to translate IRU into DataScript for migration?
Sure. So if you're doing something like, you can take something like for iRules, which is F5 scripting language, you could take something like your bigip.conf and drop it onto an Avi controller, and it'll convert that to the Avi config. And then from there, you can load it. And then from there, you can, on a per virtual service or per application basis, that'll go and take a 200,000 line bigip.conf, for instance, convert that to the Avi config, and it'll show you and tell you which things it could and could not translate. It will translate basic iRules that are doing things like redirects, HTTP to HTTPS, basic content switching and such. If you're writing anything more complex than that, then it will ask you to have a human being go and step in and kind of help out with that. So that's something where we've got people that do this for a living and can help you with this. I always like doing a few of them once in a while because back in the day, I used to be very, very, very actively involved in the iRule development during my previous job when I was working at F5 for 13 years. So I'm hugely familiar with that, but we have a lot of other folks as well on our team that help with that as well. But a lot of times you'll be surprised at how often, literally more than 75% of the time, where we're simply just going to eliminate the iRules altogether, which is pretty cool because it just makes your configuration a lot cleaner and easier.
Okay, great. Thanks everyone for attending this webinar, and we're going to conclude it. You'll get an email with the recording and slides, and feel free to reach out to us offline for any questions. Okay, thank you. Thank you, everyone. Have a great
Thank you very much.
Yeah.